Okay, good afternoon, guys. So just want to talk about the part 1 of 6.2. So it's the disk and the washer method for finding volume of object revolving around x or y axis. So let's just record that the area of a circle. So the way to find the area of circle, which is pi r square, if you guys remember that. So area of a circle, which is pi r square. So this method, so the integrals of capital A of x from a to b. So think about this way. If you integrate the area, guess what you'll get? You'll get the next dimension. The next dimension will be the three-dimensional, so which is the volume. So back to geometry. So the way to find the volume of a cylinder, it's always pi r square times the height. Okay? So depends on what kind of disk that you have. So depends on whether that's considered vertical or horizontal. If that's horizontal, so it's the integration of the area of a of y dy. So dy, which is the height, and then c to d. So now we'll take a look at that, the graph model. So if that's considered a vertical, so the left hand side right here, so it shows that pi integral from a to b r squared of x. So the curve right here, so this one is just the radius r of x. So one thing that we notice, pi r squared, that will give you the area of a circle. So the cross section here, this one is just one of the indicator for the cross section of a circle. So it's like a bunch of discs around the curve right here. So once you revolve it, so it's going to be the volume. Okay. So here's another one. So if that's considered a horizontal, so it's integrations from c to d, so it's r of y dy times pi, and then once you revolve around the y-axis, so you get the volume, so you get like a pi cone shape. Okay, so most likely, so for this one, it's going to be like this, kind of like a pi cone. So here's the top surface, and here's the bottom. And for this one here, it's quite similar, so it's a sideway. So this one is the surface. So we just turn it around. Or you can say that's kind of like a bow. A bow, okay? Okay, so what we got here, so that's the volume for this method. And as you may see that right here, so this one is just like a bunch of discs circulating around. So once you integrate all the discs together, you'll get a volume. So the area of the small disc, medium, large. So this one too. So it's like a bunch of area of a disc around. That's one. Here's another one. So that's just the cross section. Okay, so now let's see what else that we have. So for the washer method, it's quite similar. So let's say that you need to find the area of the shaded region for these two discs. So the way to do it, it's the area of pi times the outer radius square minus the small radius square. And let's say that we do have a paper towel, and you want to find the volume of the yellows regions, the solid here. So the way to do it, it's by using that v equals pi times the difference of capital R square minus little r square times the height. So that's the way to find the volume for the paper towel. So in terms of the washer method in calculus, so the way to apply this, so it's an integral from a to b, r of x quantity square, it's a big R of x quantity square minus the little r of x quantity square, and then times dx. If that's a horizontal one, it's an integration from c to d, capital R of y quantity square minus little r of y quantity square times pi and times dy. Okay, so we're going to be using all this type of formula for the next part of the video. So, and make sure that you watch part 2 of the lesson today. Okay, so thank you for watching it, and I'll see you next time.